Hello and welcome to Master of Nan. We're going to do kind of an episode 4.5 of the How to Analyze Training Data series because I wanted to show you how to inject some Nan values, and giving with the name, into the data. Because the data we previously had from episode 4, which you can see up top here in the comments, is essentially perfect data. So it has no issues with it. There's no missing values, nothing like that, because we created it from scratch to be perfect, right? But the real world's not like that. So imagine that you have a system that maybe isn't fed by an application that's hand-jammed by individuals. So you're going to have inconsistencies with the data. So we're not going that far in this series, but I'll show you how to inject some NaN values just to make it so that everything doesn't sum correctly and doesn't count correctly. So with that, we'll kind of scroll past our little comments section here. You can see our standard imports up top, except this time I've also added the random function. You can see I've highlighted that there. And we're going to import the Horizon All text file that we created in episode 4. So here's our file, and as you can see, it looks totally perfect. Just to remind you, we have about 11,000 rows in this particular data set, and we've got about 8 columns here. So moving down, what I've done here is I've actually encapsulated all of the error injection into a function with the arguments of data frame, target column, and error percentage. So data frame, as the name denotes, takes a pandas data frame. Target column takes a string, so the name of the column that you want to target. And error percent takes a float. Right here, in the very first line, we've created a copy of the data frame inside the function called df. Moving down, we've taken the error percentage, so what's passed through as the argument, and multiplied it times the length of the data frame, so the length of df. Then we've rounded it and turned it into an integer, right, because we want it to be a whole number. And then we're going to call that error total. And we'll come back to that in a minute. Take that out of there because that was bugging me. And then we have the target column. So with the target column here, we're just making it its own special data frame by using the locate function, or locate method of the data frames here. We're going to get all rows, and then we're going to pass the string argument here into a list so that it makes this target column variable a pandas data frame. Next, we're going to take the indices from the data frame, push them into a list. We're going to take a random sample of those with the total value of error total, right, which gives us how many we want based on the percentage. And then it's not weighted at all, which is why counts equals none. And that's going to be our error index variable, right? So this ends up being a list of indices. And it is unique. It's actually a set, but in list format. So unique values, unique indices. And then changing this into an actual set, we're going to do some set math here and subtract the values that are in the error index from the values that are in the overall target column index, and then turn that into the good index. So the error index is what we want to inject errors into, and the good index is what we want to keep. And then we're going to do just some debugging to make sure that there's nothing wrong here. We're going to take the length of the good index plus the length of the error index, and that should equal the overall length of the data frame df. All right, so moving down, now we're going to separate each of the columns within the target column into separate data frames by using the index location method on the target column and then specifying the rows as the error indices and then the good indices. So now we have these two files called nan column and good column. Then we're going to take nan column down here, use the index locator function, call every single value in there, make it equal to numpy nan. Right? So this is going to give us nice nan values to deal with. Then we're going to go down, finally, and we're going to concatenate nan column and good column back together on the row axis. So that's axis 0, and call it final column. And then we're going to do some more debugging and assert that the length of final column equals the length of data frame df. Finally, we're going to take this column and override the target column in df. Now when we do this, it's going to give us a nice copy error, as you'll see here in a moment. So let me scroll up here. So here I've created a variable called df new, and then I have my functions, so insert nans. I'm passing the data frame data, which if you recall up here at the top is our original data frame. I'm going to target the course date column, and then I want to take about 10% of that column and make it nan. So here we go. We're going to execute that. And now it's going to give us this error about inserting values onto a copy of a slice. That's fine. We know we did that when we made our function. Next, we're going to take another variable called df new2, run the function again, except this time instead of passing data, we're going to pass df new. So we have our data frame that already has errors in it, and we're going to inject even more errors, except this time we're going to target the course hours column, and then we're only going to inject about 5% errors because we assume that, I don't know, I'm just making up the rules here. So we assume that there's less hours, less errors in the hours. So right here, again, it gives us that same warning, and then it prints the length of this as 11,540, which matches this, so that's great, and that's what we want it to be. And then lastly, we'll output it to a file. I'm actually not going to do this because I already have. And then that's how we have errors, how we inject errors into our data by targeting different columns. Now, if you want to, you can use the same technique, the same random sample technique that I used right here, up here in the error index variable. You can use that same thing to select, let's say, the number of indices and then just like take out entire rows if you want to. However, in this case, we want to keep the rows we have and just put errors into discrete boxes within that data frame. So with that, this has been episode 4.5 of Master of NaN, how to analyze training data. Thanks for watching. Please subscribe to my channel.